All right, so today I'm going to find the focus points of the ellipse. Yesterday I kind of explained what they were. I didn't do any work on how to find anything. I just kind of showed what they are, what they can do. So today I'm just going to do an example on how you can find your focus points. All right, so here's a general form of the equation for an ellipse. This is the general form. It has a lot of letters, but don't be confused about it. All these numbers and all those variables, H, K, A, and B, they all mean something. So if you know where H, K, A, and B are located, you're pretty much on track to kind of getting how this whole thing works. All right, so the first thing you want to find is your center. The center of your ellipse happens when you look right here into the parentheses. Switch both of those signs and write whatever those numbers are. Write them back down. You switch the signs, write them down, and what you'll have is a center. All right. Now, you look at these denominators. Now, A represents your semi-major axis. That's half the length of your longest axis. All right. B represents your semi-minor axis. That is half the length of your shortest axis. So, in other words, it means it'll do something like this. So, if I know A is my semi-major axis and this is my center, then I go A units in that direction. All right, now, if I know B is my semi-minor axis, then I go B units in that direction. And notice, A is longer than B. And what I found are 2 points that I could put dots on. And then you just have to imagine what would happen if you flip everything over your axis. So if I go this many units up, I can go the same many units down. If I go this many units to the right, I can go the same number of units to the left. And what happens is it allows me to get 4 dots, and those 4 dots happen to be what I need to create my ellipse. All right. That's how we create it, by looking at the numbers. So here's a sketch of what that could possibly look like now. So I find the center, I move that many units in that direction across my major, right? And then I move a certain amount up across my minor. And then when I arrange a dot, 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 then it gives me that oval shape that I'm looking for. That's how we use this to figure out what that shape looks like. The type of example that I will work on today is going to be a general form at the origin. All right. So I'm not going to really worry about moving my center around. My center is going to stay at the origin just to keep everything neat and simple. All right. So this is going to be the type of equation that we're going to look at, the one that looks most closely to this one. All right. So once again, certain things don't change. Remember, A squared and B squared are just placeholders. We like to use the letter A so that we know which one is going to be the major axis and which one will be the minor axis. So if A squared sits under the X, we know that our major axis is on the X axis. I could have switched A and B around, which means my major axis would have been up and down instead of left and right. That's all that means. So don't get too confused or too locked in on A has to be here, B has to be there. A just represents the one that we want to call the major. B represents the one that we want to call our minor. That's it. All right, so here's my example. I have x squared over 25 plus y squared over 16 is equal to 1. All right, so I'm going to write down a couple of things that you should be writing down first before you start really worrying about what to do next. Always gather like your given information first. There it is. So that's where you look first. You look up here where I'm pointing first. Now, if it had parentheses around that x and it said like x minus 2, or if it had parentheses where that y is and it was like y minus 5, if you had those extra numbers, then you know that your center is no longer at 0, 0. You get what I'm saying? So just based on that alone, there's no extra numbers being adjusted up there where my variables are. I know that I'm centered at the origin. So that's the first thing you can write down is your center. All right, so the center is 0, 0. All right, the second thing you look for, see, look here second. You see that 25 and that 16? There's my A squared and there's my B squared. Now remember, whichever number is larger, that's where you say A squared is located. Remember, because A squared doesn't have to be under the X. A squared is what we need to put towards the largest number so that we always can point out there's my major or there's my semi-major axis. All right, so here we go. We have A squared is equal to 25. We have B squared is equal to 16. Now, if A squared is equal to 25, then that would mean A is 5, because 5 to the second power is 25. So if B squared is equal to 16, then you know the B itself is equal to 4. So those are what you're going to locate, your A and B. And part of being better at mathematics is knowing what numbers you're dealing with and being able to interpret them properly. So notice how I'm putting all these little notes along next to what I'm doing. This allows me to keep on track as to like what things will go when it's time to put it all together. It's also good if you're a student and you have to turn in work, right? If you're communicating to your professor or to your teacher, the person that has to read behind what you're doing, you're pointing out everything anyway. You're making it easier for them to understand what you are saying, all right? Because once you hand your paper off and walk away, only your work can speak for you. You won't be able to speak up for yourself anymore. So you got to be able to make sure when you communicate properly so that when you walk away, this can speak for itself. So notice right here, I have an x-axis. It says a long x-axis. And the reason why I wrote that is because this number 25 is under my x value. So that's already letting me know I have a major axis, and my major axis is going to be side to side. So it's going to be short and fat, and it's not going to be tall and skinny. So everything that we just did up until this point is going to give you the general shape for your drawing. All right, that's going to give you the general shape of your ellipse itself. So this part is important. But remember, my goal today is just not getting this information down. It's to find 2 points in particular, and those are my focus points. Because remember, it's those focus points that can do all the cool stuff that we talked about when we were applying things into like different fields. Those focal points are what does it. So we're going to locate those. All right, so this is how we're going to find them. Now, there's a reason why this works. I'm not going to get into that story. That's another 10 minutes maybe, so I'm not going to go into all of that. Just remember, if you want to find your focal points, your focus points, foci, whatever we like to call them, right? That's plural for focus, all right? So here we go. We have C is equal to the square root of A squared minus B squared. And remember, it has to be A squared minus B squared, because remember, A squared is going to be larger than B squared, because we don't want to get negative numbers under a square root sign. That goes into a whole nother branch of mathematics we're not going to talk about right now. And every number that I just used so far on these lines here came directly from the original problem. So it's nothing hard about it. Just know where your labels are. You can put things in its proper place. So A squared minus B squared, right? That's 25 minus 16. That's a 9. But if you take the square root of 9, bam, you got 3. Any questions about that? I think we should be straight there. So 3, that's how we're going to use this number to figure out where the focus points are. All right, so I got this is equal to 3. Now, remember, I had a center at 0, 0, but this 3 has to go in here somewhere. And remember, our major axis was along the x-axis. So I do a plus or minus 3 on the x variable, and that lets me know that I have my focus points going side to side on my x-axis. Wherever your major axis is, that's where your plus or minus goes, all right? So plus or minus 3 on the x variable instead of the y variable. And that's how it works. So all of this work that we did, where we found our A, our B, we wrote down what our center was, and we found out what our C was so that we can do our plus and minus. It all boils down to this right here. I know my north, south, east, and west. I know where the center of my ellipse is, and I know where my 2 focus points are. And all of these come directly from the numbers that we just worked out. All right, so the only thing left to do now is, now that I got all of that information kind of laid out right there for you to read on the board, I'm going to just show you how you take all of that information, throw it onto a graph, and you have a sketch. All right, so 0, 4 is there. 0, negative 4 is there. So there's my 2 dots. 5, 0 is there. Negative 5, 0 is there. So I have arranged my dots, And those 4 dots represent how my ellipse is going to be. All right. All right, so there's my ellipse. Now the only thing left to do is get my focus points. 3, 0, negative 3, 0. 3, 0 means I go over 3 times. And there it is here. And then the other one is back 3 times. 1, 2, 3. There it is. There. And there they go. And that should be exactly what we were able to get on the computer screen, calculator screen, or whatever software that you use. When these are doing these calculations for you, basically they have already been programmed to do the work. You get what I'm saying? So this is how, or this is the engine behind what gets all this stuff working, is what we do on the board. That's pretty much all that I have for today. That's how it works. Not only do you know what they are useful for, ellipses and stuff, now you can see how you can pull numbers yourself. You can graph them. You can find those focus points.